All right, 5.6a is about what we call the empirical rule. So the standard normal distribution looks like this bell curve right here that we have on the screen. The 65, 95, 99.7 rule. That's the empirical rule. Okay, so you will hear that referred to as empirical. Okay, so you need to learn those percentages, 65, 68, 95, and 99.7. So what is it talking about? It's saying if you have a normal curve like this, that 68% of all the data will fall within one standard deviation from the mean. Remember, the mean is right here in the middle. And this is one standard deviation out either way. So 68% of the data fits within one standard deviation. Then if you go 2 standard deviations out, that encompasses 95% of all observations. Okay, that 68 is included, but 95% of all of them will fall within 2 standard deviations. That's why you see a 2 down here and a -2 here. So it's adding 2 or subtracting 2. And then 99.7 of all observations fall within 3 standard deviations, above and below the mean. This is what we call the empirical rule, and it's just an estimation, so you use it when they tell you to use the empirical rule. All right, so let's look at the next slide. Now, don't let this overwhelm you. This is the same thing we just talked about, okay? One standard deviation, so here's the mean right here. If I go one standard deviation out above and one below, that's 68%, okay? So the only thing that's different on this slide is it took my 68 and it split it down the middle, and 34 goes here and 34 goes here. All right? And we said 2 standard deviations out comes all the way out here, and that would be 95%, right? So where does this 13.5 come from? Well, here's what's going on. If you take that 95 and you subtract 68, that middle chunk, you're going to get 27. Well, if we split that 27, because some of it's on the left and some of it's on the right, if we split that by 2, we get 13.5. So 13.5 is that little bitty area right there between 1 and 2 standard deviations. All right? Still, the total area from 2 standard deviations out is 95. Now again, we go one more standard deviation out to 3, and we have 99.7 of all observations are within 3 standard deviations. Okay? Now, same song, second verse. Here's what we're going to do. How did we get this blue area? Well, we take 99.7, we subtract the 95, and we get 2.7. If we divide 2.7 by 2, we get 2.35, and that's where that 2.35 comes from, right there. Okay? And then the very teeny tiny little tails is 0.15%. That's the rest of it, because all of it has to add to 100%, right? So keep in mind these percentages. I encourage you to write them out, recalculate them out if you want, but this is the same rule we talked about. It's still 68, 95, 99.7, but this way it breaks it into the different jumps of standard deviation, and that's helpful as you do a problem. All right, so let's try an example of one of these problems. The weights of 9-ounce bags of a particular brand of potato chips can be modeled by a normal distribution with a mean of 9.12 ounces and a standard deviation of 0.05 ounces. Let x equal the weight in ounces of a randomly selected bag. Use the 68, 95, 99.7 rule to approximate. So you can see I've drawn the same drawing we had on the previous slide. But what I need to do before I proceed is figure out, okay, what do these different boundary values between each of these percentages, okay? So if the mean is 9.12, that goes right in the middle. And then standard deviation is 0.05. So I'm going to add 0.05 for each boundary I need over here. So this next one would be 9.17. That's one standard deviation out. 2 standard deviations out would be 9.22. And then one more would be 9.27. All I'm doing is adding 0.05, the standard deviation each time. Now going to the left, I'm going to subtract the 0.05. So 9.12 minus 0.05 gives me 9.07. 2 standard deviations down would be 9.02, and 3 would be 8.97. All right, now that I know that, I can address the problem. It asks me, what's the probability that x is less than 9.02? So I look at this. Okay, where's 9.02? It's right here. Okay, so what's less than? Less than goes to the left. So all I have to do is add up those percentages. 2.35 plus 0.15, which gives me 2.5%. And that's my answer. That's all I have to do. Now let's look at the next part of this problem. Same scenario, different question. All right, I'm going to put in those boundary values again that we just had. All right, so my boundary values are in. Now I look at the question. It says, what's the probability the bag weighs between 8.97 and 9.17? So I look at my graph and I section off what is that I need. I need all of this section right here. So what do I have to do? I simply need to add up those percentages. So what is it? 2.35 plus 13.5 plus 34 plus 34. All right, so I take my calculator out and I add those up. And I get 83.85%. Okay, so the picture is very, very important. You need to make sure you draw the pictures, label the boundaries, and know your percentages for each of these little slivers of the graph. If you know those, this is really easy. Okay, hopefully this makes sense, and we'll see you in class.